with polynomial multiplication. Now, all of you are already aware, as I have said, of what a polynomial is. Does anybody indeed remember something about the word polynomial, which you learned, as I say, in the 9th grade? Does anybody remember anything about the term polynomial? No? My good friend Paul Edgar Nomial, Paul E. Nomial. Anyway, nobody remembers anything about what a polynomial is. None of you. Not a word. Really. Oh, what? Pardon? Multiple something. Okay, all right. Yeah. In teacher school, they tell us never to say no when you're asking the class for stuff because it makes people uncomfortable and it makes the kids that are scared not want to talk. So, multiple somethings. Yeah, there's certainly multiple things in polynomials. Good job, Abresia. Anybody else? See, that's 6 years of teacher school talking right there. Nothing? Oh, well, okay. Is a math, it looks like we're going to have some disappearing ink here. That's cool. Is a math expression. What makes something an expression? As opposed to an equation. Ooh, we'll come back to that later. A math expression containing a mix of, now here's going to be 3 words that you guys all know, but you might not remember what they are. Okay? It contains a mix of variables, which I'm going to highlight yellow, and you'll see why in a moment. It also has coefficients, which I'm going to highlight blue, and you will see why in a moment. And it contains constants, which I will highlight in, I feel greeny today, and you will see why in a moment. Do any of you remember what any of those words mean?
Isn't it a coefficient, like the number in front of the name?
You're going with the coefficient. The one word there that I thought nobody would ever say, that's the one you're going to go with. You're absolutely right, Caitlin. It's exactly what a coefficient is. Good job. When she defined coefficient, she used the word variable, though, too, right? So what's a variable? The letter. Excellent. So you got 2 out of the 3. Nice job. So I'm going to start with variables. Variables are, now, Caitlin called them letters. Need they be a letter? No. Because when you guys first learned algebra and your teacher didn't call it algebra, you were already using variables. You remember this question from grade 3? You remember seeing that on a worksheet in grade 3 where the teacher left a blank? Why did the teacher leave a blank there? To find what that was, yeah? Which means that's an unknown, isn't it? Now that we're in grade 10, what do we put there instead of a blank? X. But for some strange reason, Mrs. Bad Crumble did not tell you that that was algebra. If she had told you that was algebra when you were 7, learning it the first time, then you wouldn't be scared of algebra in grade 9, which is when we start calling algebra algebra instead of just math. Because when you do that, everybody can do it fine. Put an X there. Oh, no. So you all know what a variable is, but it need not be a letter, but we use letters. So a variable is, I'm going to say it is a symbol representing an unknown number. An unknown. Because that's what a variable really is. Coefficients are numbers that do what to variables? Caitlin already told us. She told us where they live. What do they do? The big number in front of a variable. Caitlin was absolutely right. What is it doing? Multiplying. Right. Numbers that multiply variables. And finally, what's a constant? Yeah, it's just a number. Okay? Everybody cool? So if I gave you something that looked like this, x squared over 6 plus 3. That's a polynomial. Why? Is there a variable? Yeah. Is there a coefficient? Yeah, because technically it's 1/6, isn't it? Because x divided by 6 is the same as multiplying by 1/6. Everybody cool? And 3 is 3. Always. Everybody okay with that? So if I were to take my highlighters, there's my variable, there's my coefficient, and there's my constant. Everybody cool with that? Now, there are certain things that are not allowed in polynomials, okay? So I'm going to put a big X here. No, X is bad because we use X for variables. No irrationals and no variable denominators. Those two things are not allowed in a polynomial. Okay? Everybody cool? Now, you actually already know that from the 9th grade. Maybe your teacher didn't use the proper words. Maybe you forgot the proper words, and now hearing them, they're like bubbling up to the surface of the math section of your brain. None of this should be new words to any of you, are they? I can guarantee they are not new words to 6 people in the room because I taught 6 of the people in the room. Everybody has seen this, yes? Okay. Now, next, I'm going to highlight the 3 types of polynomials that get special names. Okay? Do you remember this? A monomial has one term. Now, the word term I am highlighting as well because it's complicated. For some reason, it gets in people's heads. A term is any combination of multiplied. Please highlight multiplied. Any combination of multiplied variables, coefs, and constants. So in red down here, I'm going to put a couple of examples. Everybody is okay with the easy ones. Everybody understands that 2 is a monomial, right? Because it's a single constant, one thing, right? Everybody is good? Most people are okay with this, 2x being a monomial, because it's a constant and a variable. I mean, it's a coefficient in the variable. Everyone's okay with that. And everyone's like, yeah, that's a monomial. I'm all right with that. Here is when it gets confusing. 2ABC. People don't want to call that a monomial because they see 2 and then 3 variables. They see 4 things there, so they don't recognize that that is one term. Is everybody okay with why that is one term? It is because they are all multiplied together, yes? That will give us one single value. Because if we know what A, B, and C are, we know what this is, don't we? Everybody cool? So even though there's three letters, it's still a monomial, or one term. Good? All right. So you guys aren't stupid. A binomial must be two terms, because bi for binomial is the same as the bi in bicycle. All of you thought I was going to use a different word there. Two terms. Now, if multiplying is what keeps us together as a term, does dividing keep us together as a term? Yes or no? Yes, because multiplying and dividing are the same thing, right? Dividing is just multiplying by a fraction. So division and multiplication keep us together. What are the other two kinds of math? Add and subtract. That's what splits us apart. Everybody understand? Okay? So a binomial is two terms. What does that mean? It means two monomials, which we've already discussed up here. Two monomials separated by what? By adding or subtraction. All right? So, in red, I'll do the example. 2x plus 2. Binomial. A single monomial and another one. Everybody good? Okay. 3xyz plus 4abc. Still okay? Everyone's good? Okay. 2 fish plus 3 lightning bolts. Still okay? Doesn't matter what it looks like. Everybody good? Okay, now I want to mess with your heads a little. Don't write this down, just think about it. 2x plus 3x. Monomial or a binomial? Antonio? It is absolutely a monomial. Why?
Because you could write differently and then it would be x times 7 brackets.
It's 5x. Right? There's 2 x's there and 3 x's there for a total of 5 x's. Everybody okay? All right. And finally, the trinomial has 3 terms. So what does that mean in math speak? 3 monomials. Okay? Everybody good? I'm not even going to do an example of it because we're okay with that now. Yeah? After trinomial, there's no fun names. There's not a quadrinomial and a quintinomial and a sexanomial and a septinomial and an octinomial and a nonomial and a decanomial. No. They're only polynomials after a trinomial, which kind of makes me sad because I like having fun names for things. Everyone is good? None of that is new. All of you already know that. It's somewhere in your math brain, right? Even if it was buried super deep, like below the part where you understand negative numbers. I don't care. You all know that, right? Yeah. The next thing is something that may or may not have been taught to you in the 9th grade. It's not really important until you get much further up in math. So I'm just going to mention it. The degree of a polynomial. And that is simply the highest sum. What math is sum? Addition of exponents in any one term. However, there's a rule. We only use variables. Okay? So, for example, A is a variable, yes? Because it's not a number. What exponent does that variable have right now? 1, because I didn't write it. So that would be degree 1. Everybody cool? A squared would be what? Degree 2. What would AB squared be? Degree 3. Because you add the 2 and the 1. Got it? And finally, the only other trick that goes with it is this. A squared B squared plus A squared B. What degree would that be? Degree 4. Why, Caitlin? Because that guy is 4, that guy is 3, so the 4 is the degree. Everybody cool? For your purposes, what? Sorry? I'm about to tell you. That's what's in the next box. For your purposes, and even for your purposes, I don't even really care about this. When you get higher up in math, Antonio, if you choose to go higher up in math, you end up with really long polynomials. And math guys agreed to write them in this order. You put the biggest degree first and the first letter alphabetically first. Understand what I'm saying? So if I had this, and you don't need to write this down, this is so not important to actual math. Don't fill your head with this, but this is where you're going with it eventually. If I gave you this, A squared B minus ABC plus ABC squared. To write that in proper order, you would want the A squared first, the first letter in the alphabet with the highest degree first. And then you finish all the A's. And then you would move stuff around. If there was another one here like A, D, then that would go up here before you started doing the C's. Understand? Yeah, exactly. It's not important. Taylor. Oh, my hose? You guys got it out?
Yeah.
Holy crap! You guys? See this little piece of hose? And that little hole? That's $800 to repair. $800. Or free, and it takes 12 days. That's awesome. You guys need these clips, don't you? Or do you get me one? You'll probably need those clips.
So we're going to use
Oh, cool. Neat. That's spectacular.
Yeah.
Any chance of today? Early next week? Cool. Thanks, Taylor. Anyway, as I was saying, Antonio, it's only for writing them out in the order that math guys like to see it in. I don't care. Your university prof might. Nick, will their profs care how they write their polynomials? There you go. Sorry, Mr. Price. Will they care? No. There you go. Straight from a guy who's about to get a math degree. They're not even going to care. Maybe if you become a doctor of math. Calculator. Get it? Like a doctor with a nurse? You don't really believe that, Sammy. It's hurtful. But see, then when I say stuff like that, you laugh, so I know you do believe it. You're just trying to be mean to me, but that's okay. Haters gotta hate. All right. So, yeah, ignore that. Okay? You don't, I don't care. Okay? I have kids, they're like, Mr. Myers, I got the right answer, but I didn't know how to write it in the right order, so I left it blank. Oh my God. Don't do that. Just write it down. One day I'm going to miss and actually stab myself in the eye. That's really why I wear glasses a lot. It's more for protection. Okay, now, again, we're going to move on to something that you guys already know. I'm only going to do this once. Okay? I might do it once more because it can be a little bit helpful the first day. These two things are the same thing. I'm not going to actually give you algebra tiles and have you play around on your desk. I'm not going to because we lost a week of school. I'm going to show you what this means. What does this mean? Well, what I have here is technically a monomial of 5 multiplying a binomial, which is x plus 1. Agreed? So how many x's am I going to need in the answer? That's the problem. You're only going to write 1, but how many are there really? Pardon me, Mark? 5. That's why I like to show this once, okay? So, the binomial, if you remember this, looks like this. That's what an x looks like, and it's not colored in because it's positive, and that's what a 1 looks like, right? You guys all saw this last year, you should have. Now, to do this properly, how many of those do I need? 5, right? Because it's 5 times x plus 1. So I would have to draw this 5 more times, wouldn't I? Everyone cool? And we could do that. You don't need to. I don't really care. You don't need to. This is just a review. And you probably did something like that last year, yeah? With any luck, your teacher went a little bit further and showed you this. Oops. There's 5 there, because that's 1, 2, 3, 4, 5. And there's our x plus 1. And hopefully you drew it a couple of times. You drew this out. And the answer was 5 x's plus 5 little guys, right? And hopefully your teacher then said, okay, you've seen that, you get it, you understand it. Here's what you're really doing. 5x plus 1 equals 5 times x plus 5 times 1, which is 5x plus 5. And then I hope your teacher showed you this, which is called distribution. Your teacher may have given it a fun little name like flying arrows. I hate that. I call it what it is. Just like Sammy's name is Sammy, so I don't call her Colette. Okay? I don't give fun names to things when they have a name. That is called distribution. So that's what I call it. Some of you come from other schools or other places where the teachers have all these cute little stories about how this is a wall and this is the Prince Charming trying to break in. Right? Hey, Nick, do professors have cute little stories? Or do they say numbers? There you go. All right? That's the wrong cup. I'm not drinking out of that today. Everybody remembers this, yes? Okay. So up until now, this has been review of grade 9. Algebraically, that's what we just did. When you turn your page over, what we just did was this. What happens officially is 5 times x plus 5 times 1 to get you 5x plus 5. What you're doing is draw an arrow, write an answer, 5x. Then 5 times positive 1 is 5. Everybody good? What that is the distributive property. And the distributive property simply says this. The coefficient before a polynomial multiplies, and please recognize I'm capitalizing it for a reason, multiplies by, and I'm going to capitalize this word too because I've been teaching math for 17 years and everybody forgets this word, by every term in that, not the at, in that polynomial. So here is what I mean. There's a couple of things you have to worry about. Every term might have a coefficient, and it might have a variable, and it might have a different sign, positive or negative. So here's what it looks like in math speak. A, B plus C minus D. The answer is A times B plus A times C minus A times D. Everybody okay with that? Everyone forgets the second and third term. Always. That's where kids make their mistake. So, let's look at this one. I say to show a pictorial example, I don't care. If you need to draw it, go ahead and draw it, but I'm not going to make you. All right? Algebraic means, do I have a coefficient? Yes. Do I have a polynomial after the coefficient? Yes. So for this question, we're going to write it out totally what we are doing. And then on the other side of the page, we're going to write out the mental math that we would do normally. Everybody cool? So the first thing we're going to write out is this. What I have is x times 2x minus 4. Now distribute that. The coefficient has to go to the first one. So I have 2x times x. Oh, I should write that the other way. Sorry. X times 2x minus x times 4. Everyone agree? What is x times 2x? 2x squared. Why is it squared? Because that's a 1 and that's a 1 and we add the exponents, yes? That's why we do this unit after we do exponent laws. Everybody cool? And what is x times 4? 4x. We always put the number first, don't we? Minus 4x. That is actual distribution. What do we do in our heads? We don't write it out. When we get this, most of us by the end of the year are just going to look at that and say, oh, 2x squared minus 4x. What you may want to do is just draw the arrow. Oh yeah, 2x squared minus 4x. Is everybody good with that? All of you remember polynomial multiplication, yeah? And all of you saw this much in grade 9, right? Okay, so do the next one for you guys, which should be that one. Don't bother showing me a picture. Just tell me what the answer is going to be. If you're gonna make a mistake in this, you're gonna make it here. You're gonna forget to multiply the second term, or the third term, or the fourth, whatever the last term is, you're gonna forget that one. Everybody remembers to do the first one, But not everybody. The mistakes come at the second one. Everybody okay with that? All right. We are going to get out of here today with just notes. I'm going to send you away on your long weekend with possibly only one bit of homework, but we'll see. All right. Now, this one, I told you I was only going to draw things twice. This is the second thing I'm going to draw. I just want to show you how it works. How do I draw that? Who remembers? You don't even need to draw it if you don't want to. I draw a bar and three little guys. And they're all unshaded because they're positive, yes? Now, if I'm going to multiply, because this is multiply, yeah? We all know we can model multiplication with a rectangle, right? So what do I draw down here? I draw X and two little guys, yeah? Now, I fill in the middle. This X stretches this far to make one big guy, which is what? X squared. This X is to be this wide, so it's that, and that. Everybody still cool? And then that, and that. Everybody is still cool? And then 1 times 1, 3. Now, what is this answer? What have I drawn here in algebraic terms? How many x squareds do I have? X squared. How many x's do I have? 1, 2, 3, 4, 5, right? And they're all positive, yes? And how many little guys do I have? 6. Everybody good with that? So that's the answer, right? Is everyone okay with that?
No.
You don't have to be. Don't worry about it, Sammy. But do you all see how x times x got me x squared, x times 1 gets me 1, and I did it 3 times, and then 2 more times, and then I did 1 times 1, 1 times 1. Is everyone okay with what happened there? Okay, now, algebraically, what happened? Well, I had x plus 2 and x plus 3, correct? Everyone agrees? Okay. What if there was no 2 there? Pretend that this 2 is gone. What would you do there if you were writing out all the math? It would be x times x plus 3 times x, yes? Does everyone agree? Right? That's what it would be, yeah? Okay, now pretend that 2 is still there, but now the x is gone. What would you have there? What would I have? I would have 2 times x plus 2 times 3, wouldn't I? Does everyone agree? Now, what is x times x? X squared. What's 3 x's and 2 x's? Well, I have 3 x's there, and then I have 2 more x's there. How many x's is that? 5 x's. And what's 2 times 3? 6. Does everyone see how it works? Most of you hopefully saw this in grade 9, but not all of you will have saw it in grade 9. So that's why I'm going over it again. This, what you just did here, gives us this acronym, FOIL. How many of you have heard that in math class? Good. It stands for first, outside, inside, and last. Okay? So I'm going to draw out this, the one we just did. Okay? And I'm going to use highlighters. First. Okay? outside. Two outside ones. Inside. And last. Everybody got that? And all you do is you do all the multiplying, like I've done here. Everybody cool? Now, when you do that, most of you, I found this out in my other class, almost nobody had seen what I did here, which was stack them up so the x's were together. I find that easier to do. So when I am doing these in my head, I go x times x is x squared, x times 2 is 2x. Then I have a new term, so I go to a new line, 3x, and I keep the x's together because I know I got to add them, collect my like terms to get my x squared plus 5x plus 6. Everybody cool? Now, hopefully some of you have noticed a small shortcut that combines 3, 2, 5, and 6. Do you notice what is happening with 3 and 2 in the question and 5 and 6 in the answer? What do you see, Mark?
3 plus 2 equals 5 and 3 times 2 equals 6.
5 is 3 plus 2, and 6 is 3 times 2. Now, if that happens once in math class, how often does it happen? Every time. So let's look at this next question. Draw a line down the middle of your paper because we're going to do it twice. We're not going to do the picture. We're going to do it in algebra twice. On the left side, we're going to show work. On the right side, we're going to do a shortcut. What is the actual work here? First, what's x times x? X squared. Outside, what's x times 4? 4x. Inside, what's negative 1 times x? Negative 1x. Last, what's negative 1 times 4? Negative 4. Collect your like terms. X squared plus nothing is what? X squared. 4 minus 1 is what? Plus 3x. And 0 minus 4 is? Negative 4. Everybody cool with the work? Now let's do the shortcut. It's always x squared, or a squared, or q squared, or whatever. And then the middle term is what? It's these two added, right? So the middle term is negative 1 plus 4x. And the last term is what? Negative 1 times 4. And we write it out. X squared, negative 1 plus 4 is positive 3x. Negative 1 times 4 is negative 4. Is everybody cool? Okay, now I'm going to give you a warning. Listen to me now. I have just given you a shortcut. I don't normally do that because it messes with your heads. That's why I'm spending so much time on this part of it and only mentioning this for a second. Please notice. Shortcut only works when x is alone. So see how it's x and x? It's not 2x. Understand? Only works when x is alone. So x plus 1 times x minus 7, that works. All right? 2x plus 7, x plus 1. Does that one work? No. Everybody cool? Okay, now listen to me. Since we lost 7 days, I am going to be very lenient on how much textbook work we do. But listen to me. This stuff is the basis for the rest of the year, all of grade 11, all of grade 12, all of college, all of electrician school, all of physics, all of chemistry, all of everything you will ever do with math again. So, I'm not going to be too pushy about textbook work. But you'd better know what you're doing. We have lost 7 days. So, you have lost some time. Now, you guys should have in your purple book, your next page should be a page that says assignment. Polynomial multiplication. You have a different font than me. Yeah? You have to do page 104, 105, and 106 over the weekend. You have to do those. I would recommend having a look at 186, especially the ones at the end of the assignment. Most of this down here is what you're doing on those worksheets. Picking up what I'm putting down? But listen to me. Don't make this, which is really easy, isn't it? It's just multiplying and then one exponent law, yeah? Don't make this something that screws you up later on. Do you understand what I'm saying? Get as good with this as you are with 7 times 4, being 28. Do you understand what I'm saying? So do enough practice that you're cool with it. I trust you guys to do that. Okay? I know many of you are only going to do the bare minimum, just page 104, 105, and 106. That's okay. But if you are going to only do the bare minimum, make damn sure that you really get it from that bare minimum. And when I put up the right answers on Monday, you have them all correct. You understand what I'm saying? Okay? I know it says to do, there's 1, 2, 3 picture ones. If you feel like drawing a picture, go ahead. If you just want to do it algebraically, just do it algebraically. Okay? I know for a lot of people, the pictures, they can do it algebraically and they can't draw the picture. I don't think you should be punished for being able to do math. Do you know what I mean? So I'm never going to take marks away from you or say, you don't know how to multiply polynomials because you can't draw the picture. Understand? If you want to draw the picture, go ahead and try. They have a small use in the next thing we do in this unit. So if you don't want to draw the pictures, at least understand how they work. Okay? Everybody good? All right, you are going into a long weekend. Please enjoy it. Show the few old people left in our community that you give a rat's ass about them, and try to get out to a cenotaph tomorrow around 11 if you can. I don't even know where the Abbotsford one is. My kids are both in Scouts, so I have to go because they're parading. But if you can get up by 11 o'clock, it really makes those old people very happy. Often there's tears in their eyes when they see kids awaiting them. If you can do it, do it. If not, at least take a moment. When you're out shopping tomorrow, which many of you will be doing for Christmas, because Remembrance Day is the biggest shopping day of the year in Canada, if you see one of those Legion people, give them a nod at least to recognize that you do know that this is still kind of an important day. Most of the people that we care about for this holiday are dead because we're almost out of World War II veterans, and I'm pretty sure we're out of World War I veterans because the World War I ended 100 years ago, so they'd have to be about 115 to still be alive. I don't think there's many left in Canada. But there are certainly World War II veterans left, but even them, there's not that many. But let's remember, Canadians are dying daily in wars. So give them a nod, at least, if you get a chance. If you watch the video from today, that whole big preachy speech was recorded. You needn't listen to it again. You can stop watching the YouTube when you get to the end of the math. All right? Have good days. Have good weekends. See you back here Monday. The bell hasn't rung yet. It is about to ring. We'll see what happens.